Chalo. So, little bit of recap. We are studying what is known as hydrocarbons, and hydrocarbons can be classified into two heads: saturated hydrocarbons, and then we have one more called unsaturated hydrocarbons. The saturated hydrocarbons are the ones in which between carbon and carbon there will always be single bond. Right? This is a saturated hydrocarbon, and this class of hydrocarbons have got a name which is known as alkane. Right? They have a general formula which is CnH2n plus 2. This is the general formula of alkanes. Clear? Okay. And we went by some names of alkanes. Alkanes will always end with a suffix, and the suffix is "ane" with the first member with the single carbon atom, which is known as methane, where we say methane, ethane, propane, butane, that way. Okay? So today we are going to study about unsaturated hydrocarbon. One we have already studied, that you can have a double bond between a carbon-carbon atom, or you can have a triple bond between a carbon-carbon atom. Okay? The class of compounds which have double bond are known as alkene. These are alkanes. Alkene. Now, many children start memorizing these formulas. Initially, I'll write, it will become very easy for you. Look, an alkene is a CnH2n. How to remember this? Okay, how to remember this? Suppose I have somebody who is, I make an alkane out here. Okay, so how many hydrogens do I have in this? This is ethane. I have got 6 hydrogens in it. Clear? 6 hydrogen. If I want to make a double bond, all I will do is I will omit these 2 hydrogens, and I will say, hey hydrogens, we don't need you, rather we'll form the valence bond between ourselves. Now just count for this carbon. 1, 2, 3, 4. 1, 2, 3, 4. Satisfied? Satisfied. So to form a double bond, how many hydrogens did you kill? CnH2n plus 2, CnH2n. You just kill 2 hydrogen. Now we will make a triple bond. To make a triple bond, we need another 1 bond. Each bond means killing 2 hydrogen. 2 hydrogen ka gala ghod do. 1 bond form. So when alkyne will be formed, from alkene we will kill 2 more hydrogens. So what should be the general formula of alkyne? CnH2n minus 2. This is what people remember, but you should not. So this is known as alkyne. And this will be CnH2n minus 2. Let's revisit this and see once again. Okay, so we will see it with an example of the 2 carbon member. 2 carbon, and 2 carbon will always have the prefix called eth. Agreed? So in 2 carbon, first we will make an alkane. What should be our general formula? C2H2 into 2 plus 2. So you should get what? C2H6. This is known as eth, and the name ane, ethane. Eth and ane, because they belong to the ane family. Shall we make it structure? So we have got 2 carbon atoms, and rest all is filled by hydrogen. Count the number of hydrogens. We have 6 hydrogens. This is ethane. Clear? Now 2 carbon member, we will try to make alkene. So it should be C2H2 into 2, right? Because the plus 2 is gone now. So our formula will be C2H4. Name will be ethene. Let's see the structure. Carbon-carbon double bond. H. Clear? Shall we make the 3rd member of this? 2 carbon. So this is alkane. This is alkene. And then we will make an alkyne. So let's make an alkyne. So it should be C2H2 into 2 minus 2. So your formula comes as what? C2H2. This is known as ethine. The name is ethine. What will be the structure? Carbon carbon triple bond, hydrogen on this side, hydrogen on this side. Now just see H2. Does it make it clear now? Easy for you to understand? Oh, Mr. Hair Combing Man, you are at home today. What happened? Huh? Oh, okay, okay. Who had surgery? You?
Oral surgery.
Oh, oral surgery. Today he'll have soft diet, oatmeal. Is this understood? Okay? Now something we studied, that two groups will always end with, now let's see alkyne. Sorry, not alkyne. Let's see alkane. Let's see two members. Okay, let's first write the 3 carbon member. 3 carbon members name will be propane. And what should be the structure? C3H8. Yes or no? 3 into 2 6 plus 2 8. Alkane means CnH2n plus 2. So propane will be C3H8. And let's take the 2 carbon member which we just studied, ethane, C2H6. Do their difference, you will get CH2. I told you, na? The members will always be differing with CH2, CH2, CH2. Okay?
About the previous one.
Yeah. Because when the previous side was made, you were actually seeing it. See, now write. Clear?
Yes.
Shall I go ahead? Can I? Okay. So let's see alkene. CnH2n. So we take the 3 carbon one. 3 carbon means how much it should be? C3H6. Name is propene. Propene. Whereas if you take the 2 carbon, then it is C2H4. Ethene. See the difference? CH2. Ow. Here also the difference is CH2 only. Let's see alkyne. Let's see alkyne. Alkyne is CnH2n minus 2. So let's take the 3 carbon. Its name will be propyne. So C3, 3 2s are 6 minus 2. 3 2s are 6 minus 2, 4. So this name is propyne. And let's take the 2 carbon. The 2 carbon is C2, 2 2s are 4 minus 2. This is ethyne. So if you see the difference, it is again CH2. Got it? Remember this thing.
So, structure.
Which one? This one. Make the structure, your wish. 3 carbons. 2 carbons will have a double bond. Any 2. You make it from here. This is double bond. Rest, just fill up the valencies. 4 ho gaya. 1 more. 4 ho gaya. That's it. Count the number of hydrogens. 1, 2, 3. We wanted the structure of which one? This one or this one? This is this one. 1, 2, 3, 4, 5, 6, 6. You want that structure? Okay, we can make that structure also. Triple bond, carbon, carbon. Agreed? How many valencies? 1 valence is still open. 3 valence is gone. 1 valence is still open. And this will have 3 valencies. 1, 2, 3, 4. No, 1, 2, 3. Sorry, this will not be there. This will not be there. Sorry. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. C3H4. ये सब बनाएंगे, don't worry. Clear so much? Okay. So let's understand now. Go back to now. We'll for some time study only alkanes. We'll study only alkanes for some time. And we'll spend a lot of time because these are the building blocks for grade 11. Okay, so take time to understand. Alkanes. Follow the general formula CnH2n plus 2. Let us see alkanes in straight chain. Straight chain. These are known as aliphatic alkanes. Straight chain alkanes. Right? Now I won't make it that elaborated. Now there are formulas. Look, children. CH4 is molecular formula. CH4 This is known as skeletal formula. Now I will make only something which is known as condensed formula. This is molecular plus condensed. So let's start. Okay. So number one is methane. Methane. So I write it as CH4. I cannot make any other structure out here. The second one is ethane. So how do I make ethane? I make a CH3, CH3. Did you understand? Ethane is C2H6. So this is how you show. Foreign books will not write like this. Good books of chemistry will write it as H3CCH3. What is the difference? They want to be very particular that the bonding is between carbon and carbon. That's what they try to show. तो ये लिखने से भी कोई गलती नहीं है, full marks है, ठीक है? Now, our next member is who? What is our next member? Propane. Propane. Now you need not worry. To make propane from here, you need not worry because you know propane ethane differ by what? CH2. Just insert CH2. CH3, CH2, CH3. Can you make butane now? Enter another CH2. So fourth, we're gonna make butane. Butane, CH3, CH2, CH2, CH3, C4H10. Clear? I think you've got an idea how to populate an alkane series now. So if you want to make pentane, you will enter another one CH2. So this is known as, even when you go for MSc and all higher level, butane will not be shown like this. Butane will be shown like this. This is butane. 1 carbon, 2 carbon, 3 carbon, 4 carbon, all in single bond. This is how very high level chemistry will show it. Done?
Yes, yes.
Now the interesting part is when we see alkanes with branching. So that we'll learn something new now. Can I move? Okay. Let's say some alkenes with branching now. Let's see some branching. Before understanding branching, we should understand something which is known as a alkyl group. Not that difficult to understand, just absorb karo. Alkyl. Who is an alkyl? If I have an alkane, right, and I strip out one hydrogen from the alkane, I actually make something which is known as an alkyl. In somebody will pronounce it as alkyl. The same thing. From an alkane, strip out one hydrogen. Very interesting. If you strip out one hydrogen, the whole molecule will become unstable. It's like from a garland, you have just torn at one side. How do you ensure the beads will be there? The beads will come out. So you have to ensure that there is a lock in that garland. Otherwise, the garland will be losing its beads. So let's see this example. We take an alkane which is CH4, whose structure looks like H, 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 H. All we are doing, I said, strip out one hydrogen, take out one hydrogen. So if I take out one hydrogen, that is, I'm subtracting one hydrogen from here, my structure would look like, whichever hydrogen I can take out, that's my wish. It's like this. This is unstable. This is like an intermediate. Atma jaisa hai. It needs one body to get in. This is unstable. I can represent this as dash CH3. This is represented as dash CH3. Alkyl groups are generally written as dash R. Dash R. Dash R means an open valency and R represents an alkyl group. This alkyl was made from methane. So this alkyl group's name will be methyl.
So is this present in methyl alcohol?
100%. Methyl alcohol. Anything methyl you hear, this is present. Methyl. Methyl was made from methane. Methyl does not exist. Methyl is like that one extra bead which you can link to your garland, and we will see to which garland. Have you understood? So in a very nice language, do you know pub culture? Hey, do you know pub culture or not? Pubs. So in a pubs, on a Friday, you are not allowed to enter stag. You know what is a stag entry? Single entry is not allowed. So you have to have a partner. This one is single. Single but ready to mingle. It has got one open valency. This is very interesting. Open valency means this is like a end jigsaw piece which has got one link open. It can attach to something. Got it? So let's understand, if alkyl is shown as dash R, alkane can be shown as an alkyl who got paired with a hydrogen. Who got paired with an, this. Is this not an alkyl group? Yes. To make it alkene, what do? This thing is R dash. To make it alkene, what do? I put another hydrogen. So alkanes in grade 11, you will see they will be written as RH. RH stands for an alkane. Dash R means you have stripped out the hydrogen and you have made an alkyl. Is this clear? Alkyl hai kya? Alkyl is like a jigsaw piece whose only one side is open. Jigsaw puzzle to sabne khela hai. It can go and attach with its one. Shall we see now where to attach it? So similarly, from methane, when you took out one hydrogen, you created an alkyl group which was methyl. Similarly, these two are very common. From ethane, if you take out one hydrogen, you make a ethyl group. This is called ethyl. ETHYL, METHYL, methyl, ethyl. Understood? Similarly, we can have propyl also. Utna nahi padhte hain. You can have a butyl also. But your pendant cannot be that heavy that the whole necklace falls down. So pendants will have, the necklaces will have small pendant, little large pendant. Now if you put a heptyl group, pendant itself is heavier, you will be walking like this. Your pendant is heavier than the necklace. ये तो लगेगा ना जाके. चले देखिए आइए चलो. So let's see some interesting compounds now. Let's see a compound called butane, C4H10. This is a compound called butane. Okay, this is butane. I may not go by the book, but don't worry, everything in book will be covered. This is the major component of LPG, the one with which you are cooking. Understood? Let's make the structure of butane. Butane should be CH3, CH2, CH2, CH3. Make sense? Right? And if I make it skeletal structure, it is C, 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 and I have got so many H. Now you will see the beauty of organic chemistry. Clear? Butane ka pura chitta is open in front of you. Butane as shown in molecular formula, butane in condensed formula, butane in structural formula. Now see what I'm trying to make. Don't write. Enjoy. See what I'm trying to make. I have another compound, C4H10. I will not call it as butane. Just see. It is like this. CH3. Now, sorry, 1 minute, it's just not clean. Look at this compound. Let's first see the valency. This carbon should have 4 valencies satisfied, 3 with hydrogen and 1 with this. This carbon has got 1, 2, 3 and 1 with hydrogen satisfied. This carbon has got 1 here and 3 with hydrogen. This carbon has got 3 with hydrogen, all satisfied. Can you count how many number of hydrogens are there? 3, 3, 6, 3, 9 and 1, 10, C4H10. Do you see the structure here? Do you see the structure here? Completely different. These two compounds will be behaving absolutely differently. These compounds, now when you come to organic chemistries are like Bengalis. Bengalis have got 2 names. One is a name with which they call at home. One is a name with which they call in school. So here also you will see 2 names. One name is known as trivial name. And one name is known as, now many people started giving trivial name. Here he will say, a scientist in manufactures a compound, he names it like that. In grade 11, you will hear something called Grignard's reagent. Grignard actually invented it. So it's called Grignard reagent. Had she made it, it would have been named as Ananya's reagent. But this way chemistry cannot work. So IUPAC, the International Union of Pure and Applied Chemistry, said, enough of this nonsense. There will be a way in which you will name compounds, and that is one of the most interesting part of chemistry. We'll practice that also, which is known as IUPAC nomenclature. How do you name a kid here in chemistry? We'll learn that. So in chemistry, organic chemistry, you've got two names. One is called IUPAC name and one is called trivial name. You are supposed to follow IUPAC name, but if you have love for this subject, you should know the trivial name also. For example, vinegar has a component which we know as acetic acid. Now acetic acid is a trivial name. The actual name of the acid is ethanoic acid. Methyl alcohol, methanol. Ethyl alcohol, ethanol. Okay. Formaldehyde, methanol. So all these we will learn. So if you see, this is butane. This compound has got a trivial name and the name of this is isobutane. Isobutane. In LPG, isobutane is also present. In natural gas, isobutane is also present. Right? So our next item will be to study a phenomenon due to which an organic compound may have two different structural formulas but may have the same molecular formula. We have to understand this also. So we have to study a phenomenon by which organic compounds can have the same molecular formula but completely different structural formula. Understood? Aishwarya and Aishwarya. One may be a different Aishwarya, one may be my daughter Aishwarya. Names are same, but structure is completely different. So that is known as isomerism. Isomerism. You can write down. Isomerism is the phenomenon due to which organic compounds may have the same molecular formula but different structural formula. May have the same molecular formula but different structural formula. Isomerism itself is a chapter in grade 11. A tough topic here. What isomerism you are studying here is a very low level. This is known as structural isomerism. Yeah, but isomerism is a phenomenon due to which organic compounds can have the same molecular formula but different structural formula. Such an isomerism is called structural isomerism. Structural isomerism. Isomerism means a simple thing, children, where formula will be same but the compound structures will be different. Have you understood? Structural isomerism. In higher classes, you will study optical isomerism also. What is optical isomerism? There will be a compound and another compound sharing the same molecular formula, sharing the same structural formula, but when you put polarized light on it, one compound will be rotating light in one way, left side, it will be known as levo, and one will be rotating right side, it will be called dextro. So you will hear about some compounds levorotatory, dextrorotatory, LD, ऐसे करके भी आएगा. So those are not to be studied now. Now let's learn about isomerism. Isomerism. Isomerism is, children, a phenomenon due to which you can have same molecular formula but different structural formula. Is this understood? This type of isomerism which you are studying in grade 10 is a very basic level of isomerism, because when you are talking about only structural formula difference, such isomerism is actually known as structural isomerism. However, in your grade 10, see, I'm studying, making it very elaborate. When we study, do the revision of this chapter, we'll go by NCERT. Many things will be cut off, but you should know. The word structural isomerism is not used by NCERT in grade 10. In NCERT in grade 10 is making you eat only one form of noodle whose name is Maggi. But there are different noodles, yippee, top ramen, so many different types. Okay, therefore I am saying that in grade 10 what you are eating is actually Maggie. The type of isomerism you'll study is a very simple isomerism, which is known as structural isomerism. So when you go to grade 11, don't always say, no, sir had said that isomerism means only different structure. No, isomerism can be any two different forms shown by you. If the molecule twists, there can be dextroisomerism, levoisomerism, optical isomerism. So all you should know is at grade 10, if you have same. And the different, so different structural formula means what I'll get beta, I will get different structures, and these different structures are known as isomers. Isomerism will be shown from butane onwards in alkane. Now you may ask a question, sir, why is isomerism not seen in propane? Let's try to make isomerism in propane. CH3, CH2, CH3. Isomerism, this is propane. Make another one structure which has the same number of carbon, and this is an alkane, but the structure should be different. You will say, sir, I can make it. Sir, see, I have made it. I will say one tight slap on your face. This is nothing but you've just bent it. This is not isomerism. So in carbon 3, you cannot make isomerism. Isomerism will be exhibited from carbon 4 onwards. Have you understood? Is this topic clear or not? Propane cannot show isomerism. In order to show isomerism, or else you try, I'm giving you 5 minutes, make a structure which has got C3H8 but looks completely different from this. Now you know how to make structure. Structure बनाने के लिए क्या चाहिए? You should satisfy the valency of carbon. Try. 2 minutes you can try. If you want to try, you can try. Can you make a structure? Yeah.
Can you explain the isolation and
No. What do you want me to explain? Be less sensitive.
after structural isomerism?
After structural isomerism, what I said. Okay. After structural isomerism, I said isomerism means what, Shreya? One molecular formula but different structures. The name is noodles but different companies. Every company should have a name. Yippee, Maggie, Top Ramen. So we saw what? Butane, isobutane. They are called isomers. Isomers are compounds who depict isomerism. If you show isomerism, then the different forms will be known as isomers. Butane is an isomer, so is isobutane also an isomer. But I am now asking you that try to make isomers from propane. I said it is not possible. What do you have to do? You have to make one structure which is different from this, however follows the molecular formula C3H8. And you know how to make structures. In order to make structure, all you have to honor is what? You have to ensure that carbon's balance is met. बनाओ आप कोई भी structure, नहीं हो सकता है. Not possible. ठीक है ना? So let's see some isomers now. Okay, let's see isomers. So we have C4H10 as a common, what do you call, molecular formula, and this will show isomerism. So we can find two different structures. Shall I make those structures? The first structure is CH3, CH2, CH2, CH3. The other structure can be CH3, CH, CH3, CH3. Now you may say, sir, can I make it at the bottom part? Heavens don't fall. You can make it. But see, are they different structures? Completely different structures. And if you look at the bond, yes, it is satisfied. Here this carbon is attached to only one hydrogen and three different carbons. Here they are attached to two different hydrogens. Right? So the name for this will be butane. Butane. And this name is isobutane. Remember children, isobutane is a trivial name. So you will ask me now, sir, what is the IUPAC name? Hold on. For that we will learn how to name in IUPAC. Is this clear? After butane, what is the family name? Pentane. So pentane should be C5H12. This will show three different isomerism. Let's see. Okay. The first one would be obviously the straight one. CH3, CH2, CH2, and then CH2, CH3. What is the name of this? Pentane. Agreed? Now the next one I can make is CH3, CH, CH3, CH2, CH3. I will not write the name now because you will not understand. But see this structure: 1, 2, 3, 4, 5 carbon. How many hydrogens? 3 plus 1, 4, plus 2, 7, 3, 10. 3 plus 1, 4, 4 plus 2, 6, 6 plus 3, 9, 12. Matched. Valency: 3 valency plus 1, 4. 1 valency with hydrogen, 3 with carbon. Satisfied. CH2 obviously satisfied. CH3 satisfied. CH3 is also satisfied. Clear? We'll have a third one also. See the third one. CH3, C, CH3, CH3, CH3. 3 plus 3, 6 plus 3 is 9 plus 3, 12. 5 carbon. Valency, this carbon 4 satisfied. CH3, 3 with hydrogen, 1, 4 satisfied. 3 with hydrogen, 1, 4 satisfied. All are different structures. Now you will say, sir, we can make one more isomer. You will say that, which you are not saying. Sir, one more isomer is possible, and you think you should give me Nobel Prize for that. You will say this is also an isomer. Na, isme aur isme koi fark nahi hai. This is the same thing, just turn this side. Then this is this only. This you are just trying to bluff me. So this is not an isomer. 3 different isomers. Have you understood? Now one thing which you are not questioning. Little bit ago we studied about somebody who was standing outside the pub. Alkyl group. Single ready to mingle. 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 Now you see how a alkyl group is so interesting. All these are alkyl groups only. It's a jigsaw. Is this not an alkyl group? Yes. CH3 dash, CH3 dash, CH3 dash, CH3 dash. These are all alkyl groups. Your common sense makes you see the molecule in this manner, which is very common. You try to see the molecule like this. Every person will try to see it like this. There is no harm in seeing the molecule like this also. In that case, these two are side attached. You can see it like that also. You can see the molecule in this fashion also. Still, these are two attached. Have you understood? Take this as the first, this as the middle, and put this on the third. These two can be brought up and down. This is number 1. Number 2, third one is brought here. Then with the second one, these two are attached. Put one on top, one on bottom. इसमें कुछ लिखा है क्या? I am fair CH3. I am dusky CH3. No, they are just CH3. Have you understood what I'm trying to say? Okay, let's see it like this. Let's see it like this. I am deliberately now drawing it with colors. CH3, C. Understood? Now I am using colors. तुम लोगों ने कितना मेहनत करना पड़ता है यार. CH3. You are trying to see it in the combination of white, white, green. I'm changing this combination now. How does it matter? CH3, C. Which one should I bring? I'm bringing the blue one. CH3. Agreed? With this white, there are 2 more CH3s. Yellow CH3, black CH3. Yellow CH3 and not black, green CH3, sorry. Green CH3. What is the difference? No difference. समझ में आ रहा है? I have made them different in color to make you understand which CH3 I picked up. But in actual, all CH3s look alike. All electrons look alike. So that's clear. So is isomerism clear? Have you understood isomerism? Isomerism is a phenomenon due to which an organic compound, and you are taught isomerism only in alkenes, very simple. Organic compounds can have the same molecular formula but different structural formulas, and these different structures are known as isomers. Isobutane and butane are structural isomers. Have you understood? Isobutane and butane are structural isomers. Now shall we move to next topic, how to name, okay? And this is where children find most interesting. All children say, sir, one more example, one more example. So let's understand now naming of alkanes, and here we will have branched as per IUPAC, and very simple examples we will see. It doesn't come in exam now. Earlier it used to come in grade 10. Now they have removed naming, and we will see branched. Sir, why are you seeing branched? Straight, you know how to name methane, ethane, propane, right? So there are some rules, and these rules, for interest, we will do it. Okay, let's see the rules. So let's take a branched hydrocarbon, CH3, CH2, CH, CH2, CH3, right? Is this complete? It is not complete. Here we have got 4 valences. This carbon is still unsatisfied. 1, 2, 3. So what I've done, I have put a CH3 out here, right? This is now done. You can't name this because this is branched. What did I put here? A methyl group. A methyl group. Now let's see how to name it. IUPAC first says consider longest chain. Longest chain. So let's understand what is longest chain. लिखो मत, पहले समझो. लिखने से समझ नहीं पाओगे. Longest chain. What is longest chain? 1, 2, 3, 4. If you make it straight like this, then these two are on sides. How many carbons did you get in one chain? 4. There's a branching out here. Did you understand what I'm trying to say? Another is the way you see it. 1, 2, 3, 4, 5. And branching here. Another can be 1, 2, 3, 4. This is shorter. We are still winning with 5. 1, 2, 3, 4, 5. That means 2 combinations give me the longest chain. Either it can be 1, 2, 3, 4, 5, or it can be 1, 2, 3, 4, 5. Try and think, is there any way you can get a chain which is more than 5? I don't think so. Longest chain. Imagine these all breaks can be made straight. Okay, if you want to make it straight, let's say suppose you're trying to think that this is a long chain. So I'm trying to make it CH3, CH2. I have arrived at CH and I straighten it here. So that is a CH3. Then this portion, which is linked to the third one, goes here. Goes here. Did you understand? If you still have confusion, I can circle this one and this one with the right. This one and this one with the right. And I have made this as the straight chain. Possible, no? But in that, how many carbons are you getting? 4. So that is not the longest chain. Have you understood now how to identify the longest chain? Okay. Once you have identified the longest chain, you have to remember that the branching or the node, we call it the node also, or the locant, many people call it as the locant also, should get the minimum number. Now, if I go with this side, the branching is happening at here. What is the number you are assigning? 3. And if you are coming from this side, you are assigning 3. So it doesn't matter. My both chains are valid. Imagine this compound was CH3, CH2, CH, CH3, CH2, CH2, CH3. Suppose this compound was like this. Now let us name it. 1, 2, 3, 4, 5, 6. And if you number from this side, 1, 2, 3, 4, 5, 6. This numbering is not applicable because you are assigning 4 to the branch. The branch carbon should get the smallest number as possible. So, but in this case, both are fine. यहाँ से भी गए तो 3, यहाँ से भी गए तो 3. Have you understood? Once you have done these two, then identify that locant. Your locant is methyl. Who came at number 3? Methyl came at number 3. Once these three things are done, we are ready to name it. First, you will always name that number which is the branch. Where is the branch at? 3. So we're going to name this compound now. 3. After 3, you will have to specify what did you attach at 3? What did you attach at 3? Methyl. Number and alphabet will always separate with a hyphen. Methyl. Understood? And then what is your chain count? 5. 5 means what should be the prefix? Pent. Is it an alkane? Yes. 3-methyl pentane is the name of this compound. Mind you, there is no gap between L and P, and everything is written in one running hand, all in short. 3-methyl pentane. Have you understood? Now let's see the reverse. The child's name is given to me. Construct the structure. It will become very easy. 1 or 2 examples, don't make faces. It will come 3-methyl pentane. First, identify what is the alkane. What is the alkane? Pentane. So make pentane. 1, 2, 3, 4, 5. Agreed? Where is the branching? 3. Who is at 3? Methyl. Rest, just fill up the valencies. 1, 2, 3, 4. So easy. 3-methyl pentane. Let's go back to isobutane now. What was the structure of isobutane? If you remember, CH3, CH, CH3, CH3. 3, 3, 6, 3, 9 and 1, 10. 3, 4, H10. Shall we take a chance to name this? See the longest chain. One chain can be this, one chain can be this, one chain can be this, one chain. In all combinations, it is 3 carbon. Right? So it will be a pentane, pentane. In 3 carbons, whichever way you go, the middle carbon will always get the 2 number. So branching is happening at 2. This is 2. At 2, whom did you attach? Whom did you attach? We are considering this as our chain. But Ananya says, no sir, my chain is this. Still at 2, whom did you attach? Tegvi says, my chain is this. Still you attach methyl. If you go this, then also it's methyl. So at 2, you attached methyl. How many carbon atoms in your straight chain? 3. Propane. Not butane. 1, 2, 3. It is a propane on whose second carbon there is a node, and in that node who came? Single, ready to mingle. Methyl has come. Are we ready for some more naming experiences? Let's see one more. This one, when we did last year, ambulance had to be called. So let's see. You remember one of the isomers of pentane? CH3, C, CH3, CH3, CH3. And I said I'll not name it. Now we will name it. How to name it? First, identify the longest chain. How should you go? This way? This way if you go, what is it? CH3C, CH3. This way if you go CH3C, CH3. This way if you go CH3C, CH3. This way if you go CH3. So all are same. So shall we go with the easiest one? Okati, Randu, Moore. Understood? Now who will take a... First is always the name of the locant, the node. What is the node? 2. Very good. At 2, what is happening? I am carbon number 2. Who is on my head? Who is at my toe? So how do you say only 1 methyl? 2 methyls. 2 methyls. This naming gets interesting. 2, there is a branching. In 2, I have another branching. When numbers and numbers are written, they are separated by comma. And when numbers and alphabets are written, they are separated by hyphen. So at 2, what is there? At 2, what is there? At 2, what is there? Now you will say 2 comma 2 methyl methyl. If you have got 2 oxides, you call it what? Very good. So this is 2 dimethyl and then propane. 2 dimethyl propane. Let's try to name it now. This is not there and we learn to make the structure. What is the structure? Propane. First identify this. Propane. CCC. Propane means 3 carbon. At 2 there is a branch. At 2 there is another branch. Who are there in these branches? Dimethyl. Who is a dimethyl? 2 methyls. One at the bottom, one at the top. Fill the valencies. Fill the valencies. Your compound is done. Have you understood? Just like this methyl is standing outside the disco, waiting as single ready to mingle, on Friday night, there are some more chapris also who are waiting there. These chapris are known as the chapris from the halo group. Halo word comes from group 17, which is the halogen. What are halogens? Fluorine, chlorine, bromine, iodine. So these halo group chapris are written as -X. -X. And what is the X known as? X can be fluorine, X can be chlorine, bromine, and iodine. So now let's see a compound where there is a branching which is chapri there. And let's see what is its name, right? Let's take an easy compound, CH3, CH, Cl, CH3. Let's name it. Could you identify the longest chain? Now there is no question going this side. If you go this side, I'll bang your head. This is not carbon, this is chlorine. So सवाल ही पैदा नहीं होता है. अब आप ऐसे ही जाओगे या फिर ऐसे आओगे. So how many carbons now? 3 carbons. Shall we name it? 1, 2, 3. Where has the branching? 2. At 2, whom do you see? Chloro. And what is the chain? Propane. 2-chloropropane is its name. खेलो ऑर्गेनिक केमिस्ट्री खेलने की चीज है कुछ और मजेदार बनाए इसको आ जाओ CH3 C this is Cl there was an H here I kick out that H man today's Friday good night let's put bromine out here and let's put CH3 let's try to name this compound now at 2 I have a branching at 2 I have another branching but this will not work. This works when both are same, but now both are not same. So it is a little bit different. At 2, I have a chloro, I have a bromo. Chloro, chloro, bromo, iodo. Chloro, chloro, bromo, iodo. That's how you name it. So we have got, at 2, we have got bromo. At 2, we have got chloro also. Between chloro and bromo, who is alphabetically ahead? Bromo is alphabetically ahead. Arre, 2 bromo. Between alphabet and number, it is always a hyphen. 2 chloro. Then propane. 2 bromo, 2 chloropropane. Now suppose this structure is not given to me. This name is given to me. What is the alkane? Propane. Okati, rendu, more, propane done. 2, 2. There is a branching at 2. On one side, I have got a chloro. It doesn't matter whether you put chloro down or up. And on one side, I have a bromo. Children, it is same as 2 chloro, 2 bromo. Nothing wrong. But if I am a strict teacher, this one deserves more marks than a 2 chloro, 2 bromo. At your level, many times teachers give it correct. But IUPAC says, you will number it in, name it in alphabetical order. Bromo comes ahead of chloro. If you write 2 chloro, 2 bromo, heavens don't fall. 2 pe chloro, 2 pe bromo. But the right way to represent is Ananya Aditi. Aditi should come first, followed by Ananya, because in both cases, one is D, one is N. D wala pehle aayega. Then I change my name to Ananya, AA. Now I supersede her. यही तो करते हैं ना फिल्म स्टार लोग ठीक है So 2 bromo, 2 chloro, and now just fill up the valencies. Are we ready? Something else. मजा आ रहा है तो? एकदम ढिंचैक compound we will make. ढिंचैक compound. CH3, C, Br, C, Cl. Okay, CH, 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 CH3, CH2, CH2, CH3. Let's see. Longest chain. Only carbons. 1, 2, 3, 4, 5. 5. 5. 5. But 1, 2, 3, 4, 5, 6, 7. Longest chain is this one. Now, how do you do the longest chain? Let's go this way. 2, 3, 4. 3, 4. If you come from this side, what is the number you are getting? 1, 2, 3. 1, 2, 3, 4, 5, 6. Tell me, 2, 3, 4 versus 4, 5, 6. Which is a smaller number? 2, 3, 4. That means this way you are not allowed to name it. We will name it only in this way. Is this clear? How to select the longest chain? 1, 2, 3, 4, 5, 6, 7. Chale? Branching is happening where? Branching is happening at 2. Then branching is happening at 3. Branching. No. I have to make your life miserable. Right? Branching is happening at 2. Then branching is happening at 3. And branching is happening at 4. Agreed? At 2, who is attached? Chloro. At 3, bromo. And 4, what is there? Methyl. So ideally, the name can be 2 chloro, 3 bromo, 4 methyl, heptane. Right? In that case, the number you are getting is 2, 3, 4. But here IUPAC is more weird. It says no, chloro comes first. So if you honor chloro, the number becomes 3, 2, 4. Because, sorry, not chloro. Bromo comes first because bromo is B. So 3, 2, 4. But this will be allowed. This is not allowed. You have to give preference to the name. Compound kuch change nahi hoga. If you make with this also, if you make with this, you will make the same compound. So let's see whether we are able to make the same compound or not. And after that, I'll leave you. Enough, I've eaten your heads. Nobody's going to ask this question, but this is what is waiting for you in 11. So let's name it as 2, how do you name it? Chloro. Then then 3 bromo. Then 4 methyl. After that, heptane. I said that the number should have been 3 bromo, 2 chloro, 4 methyl, heptane. Heptane. Doesn't make any difference. When you will be actually at a higher level, nobody sees a difference in this too. People who are very passionate, like say sometimes while making a cell diagram, you can make the cell like this and you put plus minus, but they will say nah, plus should be bigger, minus should something like that. So people who are passionate, they will say nah beta aapne theek nahi likha hai, this is not correct, this is correct. But if you make the structure, it is all simple. So making the structure becomes very simple once you know the formula. Let's use it. What is the chain? Heptane. Okati, rendu, muru, nal, aidu, aru, yedu. 1, 2, 3, 4, 5, 6, 7. Branching is that 2, 3, 4. 2, 3, 4. What are the branchings? Go by this or go by this. Here also it says 3 pe bromo. Here also says 3 pe bromo. So 3 pe bromo. 2 pe chloro. Methyl. Now what is our job? Throw the hydrogens on their face. Morons. Take hydrogen. How much is it? CH. This will be CH. This will be CH. This will be CH2. This will be CH2. This is CH3. In between nothing means CH2. Okay.
Can I bond with oxygen?
Oxygen does not come. Halos will come. Nitrogen. So later on you'll study amines. NH2 group will come. Then this will be known as amines. Chloro, fluoro. OH group will come. Hydroxy group will come. OOH, COOH group will come. Carboxyl group will come. तो बहुत है. अभी तो just we're just seeing the animal. Yeah, it has a tail. The whole animal has to be discovered. मजा लो इसका. मजा आ रहा है कि नहीं? It's interesting. So यहाँ पे रोके आज, नहीं तो आप बोर हो जाओगे. So this part nowadays does not come in exams. Nobody will tell you that write the structural, write the IUPAC name or write the compound. But 3-4 years earlier it used to come where they will give very easy things. 2-methyl butane. Draw the structure. करना ही क्या है? Butane draw करो. 2 पे मिथाइल लगा दो. 2,2-dimethyl butane. Achha, one last compound as you all are packing. Name this. ये जरा name करो तो. What will you name this? And after this, you all are get lost. I have got one more class, but you can just get lost. Name this compound. Go by the simple method. First, identify the longest chain. The longest chain is 4, but 4 can go this way, 4 can go this way, 4 can go here, 4 can go here. Either way, this and this are same, 4. If you go this way, 4, then it is 1, 2. If you go here, it is 1, 2. Which one will you select? No. This is what, this will be either 2 and 3. Here also it is 2 and 3. But which one will you select? You all are not seeing it properly. If you go this way, there is a double branching at 2 and a single branching at 3. If you come that side, there is a single branching at 2 but a double branching at 3. Which number is smaller? First one is smaller, so we'll go with the first one. Itna main bata diya. Now can you name the compound? Whom did you pick?
Dimethyl.
Whom did you pick? At 2, 2 and 3, what is attached? Methyl is attached. कोई फर्क दिख रहा है क्या इसमें इसमें इसमें? फर्क नहीं है ना? तो नाम दे दो. 2, 2, 3 trimethyl. Yes. Butane. What nonsense here. Okay. 2 to 3 trimethyl butane. A simple thing now. If this excites you, it's not a part of your grade 10. When I revise, I will not teach all these things. These are not there. Nobody's going to come. If this excites you, your life will be, you are going with a good mindset in grade 11 to study chemistry. If this is not exciting you, then please devote more time in chemistry next year onwards, because you have to pass that subject also. So I'm being very clear. If this does not excite you, it may not. It doesn't excite everyone. Organic chemistry will become a sore of your eye. And in 11 and 12, it is more and more of organic chemistry only. 11 still inorganic, but 12 is full organic. Alkane is one chapter. So, and 2 chemistry books. Right? So if this excites you, fine. If this does not excite you, please pay more time, because whether you study maths, physics, chemistry or biology, physics, chemistry, chemistry is always there. You can't run away from it. समझ में आया? And the inorganic becomes even more boring. There's only a part called physical which is interesting because it will have mathematics. Inorganic रटते रटते पागल हो जाओगे. What is electron negativity? That electron pulls this. Modern chemistry is interesting, where you see all those Bohr's and 2n square and all those, but otherwise chemistry will become, तो ये आपको अच्छा लगता है, पढ़िए इन चीजों को. And if you think that there are topics which are not there in the textbook, I have thought you have at least written the names of those. Please go to ChatGPT, type those things and just write, discuss. You know, when I read higher end topics, every time I also don't understand from the textbook, higher level. What I do, I just cut out that picture portion and put it on ChatGPT and say, explain at the level of a 12th grader. Explain at the level of a 10th grader. which CBSE perspective? Then they will explain it very nicely. Use chat GPT to your strength. They will explain it, and in bottom they will say, from CBSE perspective, these are the 2-marker questions which you can expect, 3 markers which you can expect. Okay, after everything you've done, can you simulate few case-based questions from here? Can you simulate few assertion reasoning-based questions from here? Can you simulate few true and false questions from here? Can you simulate match the following? You are learning the best way possible. But what I will do, sir has given history homework, write an essay. I went to ChatGPT and I did that homework. बस फटीचर आंसर आएगा उसमें. ऐसे पढ़ो. Take your NCERT portion, cut out. You know what to do? Control X, print screen, post it on ChatGPT. Say, explain, discuss from CBSE perspective, develop questions, develop competency-based question, develop assertion reasoning, and you have your own question bank. And then you say, develop answer questions with answers. Even the question bank that I am giving you, upload it. It will give you the answers. पढ़ना चाहते हैं तो बहुत रास्ते हैं. If you don't want to study, then there are many reasons.